Hello everyone, this is Amir Khan from Physics Realm, and today's video will deal with mechanical properties of fluids. This in fact is the first video in a long series in which we are going to deal with all the chapters of class 11th. We will also have a different section where we will deal with class 12th and other classes. So you can check it out there also. So now, without wasting any time, let us start with the basic concepts in this lecture. Today only we will deal with what is a fluid, what is thrust, what is pressure, what are the applications of pressure, and what is density. Then slowly we will move toward Pascal's law in the next video. So without wasting any time, let us start with fluids. What is a fluid? A fluid is anything, any substance or anything that can flow. So this brings us to two things, like fluids can be gases or fluids can be liquids, because both of these things can flow. So with our knowledge of fluids, we can characterize that there are some of the common factors between them. Both gases and liquids have randomly arranged molecules. So we have common factor, which is random arrangement of atoms or molecules. Other than this, another common factor between them is that both do not have their own shape, don't have a definite shape. These are the two factors which are common between them. But there are some differences also. There is one big difference, and the difference is that gases are compressible. We can compress gases, we can make them from a big vessel into a small vessel, and they get compressed to take the space. They can expand to take the space of entire room. So they are compressible, while liquids are incompressible, mostly incompressible. For any ideal liquid, it is incompressible. We cannot compress it. This is the basis. This is one of the most basic concepts which we will deal in this chapter, incompressibility. So now, since we know about fluids and we know about their properties, we should start with thrust. Thrust, as you might have studied in class 9, is the perpendicular force acting on a body. But in case of our fluid dynamics, we would consider thrust as the force, the perpendicular force exerted on any surface by a liquid, exerted on any surface by a liquid. So since thrust is perpendicular force, that is why the unit of thrust is also, its unit is also Newton, which is denoted by capital N. 1 Newton is equal to kilogram meter per second square. In CGS, you have gram centimeter per second square or dyne. Next up we have pressure. Pressure at any point is the thrust acting per unit area at that point. Thrust acting per unit area is pressure. So since pressure is equal to force or thrust upon area, it is scalar. Pressure is scalar. And the unit of pressure is Pascal, which is denoted by capital P and small a, and is equal to Newton per meter square. Other than Pascal, we have a CGS unit, which is dyne per centimeter square. Other units of bar: atmosphere, Torricelli, millimeter of mercury are also used. So we now know about pressure, and it is nothing new as compared to what we have studied in class 9. So next up we will deal with applications of pressure. There are many different applications of pressure, out of which the first one we will study is it is easier to cut with a sharp knife. It is easier to cut with a sharp knife because a sharp knife has less area in contact with surface, and with less area in contact the pressure is larger, therefore it is easier to cut. So now how can we know this, that area is small, so pressure is large? We can know it from this equation, P equals F by A. So it means that if pressure increases or if force increases, pressure also increases. If area increases, pressure decreases, inversely proportional. So we can write it down also as pressure is directly proportional to force and pressure is inversely proportional to area. So this will mean that when force increases, pressure increases, and when area increases, pressure decreases, or if area decreases, pressure increases. I hope this is simple. So now, since the area is less when it is sharp knife, so pressure is large. Another concept is that tractors have a broad tires. Tractors have broad tires. Now the reason is the same. Tractors have large or broad tires because broad tires means larger area in contact. and greater the area in contact, lesser is pressure. So it does not sink. So we know that we already know, I have told that pressure is inversely proportional to area. So if the area is large, pressure is less, and if the pressure is less, there is less load, and if there is less load, it is easier for the tires to carry on heavy loads. Another example which we will deal is that pins or nails have pointed ends. Now those pins or nails have pointed ends. If you would have seen, they have pointed ends. The ends are pointed so as there is a lesser area in contact. So the ends are pointed for less area in contact with wall. Less area means that is larger pressure. So when the area is less, the pressure is large, and that is why pins or nails have pointed ends. One of the most common examples which we can see is that school bags have wide straps. Same again, wide straps means large area. Large area means less pressure on shoulders. That is why school bags have wide straps. Now, after the applications, we move on to density. Density is defined as the mass per unit volume of a body. So density is defined as mass per unit volume of body, where the formula for density, that is given by rho, is equal to mass upon volume, or rho equals m upon v. Since density is the ratio of mass and volume, its unit is kilogram per meter cube, and the CDS unit is gram per centimeter cube. Density is a scalar quantity. After density, we have specific gravity or relative density. Relative density. Now, relative density is the ratio of density of substance to the density of water at 4 degrees Celsius. If you might remember, water has the highest density at 4 degrees Celsius, which is equal to 1 gram per centimeter cube, and that is why relative density is equal to density of substance upon density of water at 4 degrees Celsius. Since it is the ratio of two similar quantities, it is unitless. Relative density gives an idea about whether an object will float or sink in water. How? If relative density is greater than 1, object will sink in water. If relative density is less than 1, it will float on water, and if relative density is equal to 1, it will just float on water. So that is all for today. Hope you would have liked it. If you would have liked, please do give it a thumb up. Next video we will start from Pascal's law. See you there. Until then, take care.